And then we covered this in terms of the AI implementation. Okay, so we also looked at the things that actually helps us to simulate the memory process or to do a cognitive modeling in an AI system. Okay, so yes, so the first week was always whichever topic that we do, most of the time we will always cover with introduction, okay, with a definition. So I'm not asking you to memorize all of this definition, okay. You are not a history book. So what I'm asking you to do is to understand, okay. So make sure you know what the relational definitions are. So these are on the memory aspect. So we also look at the most basic, probably the earliest memory model called the Moda model of memory by Atkinson and Schifrin. So this memory model is divided into two parts. One is the structural features and another one is the control process. So when we receive the signals from this our sensory, all our five sensories, it goes through to this level. So we will have to allow some kind of um, information to be kept in the short-term memory because we cannot keep all the information, so we have to be selective. So all of this is against related to the models, to the topics that we covered before. Okay, so this is when we talk about the STM and LTM. Okay. So then we went into the details of the STM. Okay, so short-term memory, you know that it's got its own duration and also capacity. So make sure you know them. Okay, so there were experiments that supports this. Go and look into them. We also covered the cognitive models. A lot of cognitive models actually in this lecture. One example is basically the one on specific for working memory that has at least three components. So one is called phonological loop, which is basically responsible on the verbal or auditory aspect. Another one is visual spatial sketchpad, which is on the visual aspect, and another one is basically the middleman who is responsible to pull information that comes from both phonological loop and visual spatial sketchpad. Okay, so this is basically a scenario that we have covered in our lecture that covers the integration and the use of these three different memory components, at least from the working memory perspective. Okay, so we have actually looked at other memory models. Some example are dual process theory, levels of processing theory, working memory covered just now, the difference between episodic and semantic, and also procedural memory, and memory consolidation. Sorry, question? No. So levels of processing actually refers to how the level of details that we put to keep. Okay, encoding is basically saving information in our mind. So one is called shadow, another one is deep processing. Shadow is when you just refer to certain words, for example. Deep processing is basically maybe the meaning. Deep processing basically the sound, and deepest processing is the meaning. Okay? So whenever we want to remember something, the better you are to associate with certain meanings, the better it is for you to remember. So that's why in exam, I'm not asking you to go and memorize the entire lecture content. Okay, it will not work because you're going to do shallow processing. Okay, you have to do it by deep processing, which is understanding the meaning. Okay, so make sure you understand the context and the structure of the lecture. That it makes it easier for you to fill in the blanks of why certain parts of lecture is actually being covered one after another. There's actually a structure to it. Okay, so. So we also covered the different aspects of episodic, semantic, and procedural types of memory. So make sure you know which is which. Okay. So let's say if you have a birthday party, all right, trying to remember them. Is it an episodic or a semantic memory? Okay. Just be sure that you understand the definition as well. So you remember this experiment, the diving experiment? Yeah. Do you want to apply this? Go and study at the swimming pool and then go and harass exam hall and say you want to sit exam at swimming pool. You want to do that? And become viral. Thanks to Dr. Naiza. So this is one of the ways where you can actually encode or input something that is so meaningful. Okay, so something that is so personal to you gets to be integrated in your mind a lot better. So for example, in encoding specificity, what it means is whatever situation that you have, like the test situation and the training and the test situation needs to match for you to perform at your best. Okay, if you don't have the same, or if they are in opposite settings, then your ability to recall might not be well supported. Okay, so imagine what your exam scenario or environment is going to be and try to simulate that when you study. Okay, so we also look at, so that was short-term memory, and now long-term memory. So we know that long-term memory is when we are able to keep information that comes from the last 30 seconds to what probably go as long as maybe 10 years or 20 years ago, depending on your age. Okay, so we have also covered different types of long-term memory. So one is declarative, another one is implicit, and it's got its own different structure to it. Okay, just make sure you understand the general idea of these types of memory. Okay, where is when and what happens to each. Okay, and in most of our lectures, after we finish covering the human aspect part, we also learn how AI systems can actually use that human aspect or human models to be to be borrowed for the systems development. So in this aspect, we actually compared how the different components of human memory and AI systems. Okay, so we make reference to the Moda model of memory that was covered earlier on, and what kinds of association or relationship can actually happen when we develop AI systems, okay, and for what purpose. So these are the things that you can look into, and also how AI systems can actually replicate the memory functions. So you have things like encoding, storage, retrieval, so all the things that we have covered from the human perspective, you can also do the same for developing or creating AI models or AI applications. Okay, so it doesn't necessarily have to be just one same system, but it's basically just what would be the equal component between these two. So then we give more examples of those different models in AI systems. So for example, when we have declarative memory, these are representing factual knowledge that can actually be represented in the form of GRUNs, knowledge-based semantic network, or basically subject predicate objects. So these are basically the common types of how knowledge can be represented in AI systems. Okay, it's also got this procedural memory. Then we also look at how short-term memory and long-term memory can be modeled. Okay, so these are some of the implementation using different existing AI systems, such as the AR, the was it the ICAR memory architecture that we look into. Okay, so we also covered several applications and the interaction between these two and how they are actually being implemented as a representation of human STM and RTM. Okay, so that is basically for topic 5. Then we move on to topic 6. So I've covered some aspects for topic 6 for under knowledge representation. Mainly, this aspect covers how information can be represented by two aspects known to be symbolic and sub-symbolic. Okay, so of course, first we look at what is basically the information that we want to represent in our minds. So this actually talks about some of them are more tangible, some are non-tangible. So still, regardless of which area they're coming from, they can still be represented by different aspects of in different formats. So one is basically is referred as analogical representation, another one is symbolic. Okay, so these are the respective examples or definition for each. Okay, and then we also look at the analogy between how human memory or mental representation works versus a computer representation. So if you see mental representation in the mind is almost equivalent to data structure in the computer, okay? And computational procedure is very much related to the algorithm itself. So in the minds, we have the capability to think, and running program in a logical manner is the equivalent for a computer. Okay, and then we look at different formats of information representation. Okay, so on the left side you see the information that's been represented in a logical manner, rules, concepts, images, analogy, and so on. And over here, which you can see in more detail in the slides, are some of the representation of the formal logic, rules, analogy, basically more description, more detailed description of this stuff. Okay, so you also have these in your notes where you represent your knowledge in terms of internal and external representation. You also have the details of how this is actually being represented in each one of these aspects. Okay, so all of these, they're in the notes. We covered the different areas of these terms called schema and script. Make sure you know what they are, how they are different. Okay, schema, when you look at this, you can identify whether they are schema. You can also explain the same thing using script. Okay, so make sure there is a clear understanding of this. Okay, right here. Okay, so when you see here, this is one of the experiments that was supporting the schema theory, that participants were shown this picture, and after 10 seconds or after some time, when they went to a different settings, they were asked what they saw. Okay, so, and this actually prove what we talk about in these concepts, schema and script. Okay, then we went on talking about semantic network. Okay, so semantic network is basically our ability to respond to, for example, this information. Okay, an apple is a fruit, a pomegranate is a fruit. Which one is faster? Which one is slower? Okay, so make sure you understand what is the relationship of this, why recalling one part of information is more difficult, or not difficult, longer than the other. Okay, and this is related to Collins and Coulan's model. And if you look at the notes, if you have been following, it's got some relation that's got to do with the economic costs. Okay, so we went to the second part again, where we look at the AI approach to knowledge representation. So many ways of how knowledge can be represented, but still divided into two aspects. One is called symbolic, another one is sub-symbolic. So symbolic is when we have a very distinctive or separated kind of symbol for a specific object. They're sort of like on their own, independent. Some sub-symbolic is what we get usually in a neural network, okay? Because we don't need to necessarily represent all the data that we need, but we have some kind of algorithm that can learn from this network. So it's basically learning from data. Okay, so this is basically the difference between the symbolic and sub-symbolic systems. So we went on talking about the different representation or different aspects of this paradigm. Okay, and we look at, like, say, the definition, processing, their examples, their analogy, their strength, weakness, and so on. Okay, and moving on to topic 7, we look at learning. So first of all, we covered the human aspect of learning before we look at how the AI systems can borrow these principles to create more intelligent, automated systems. So the first part is basically on cognition. What is learning? How do we learn? What makes out successful learning? And we have also covered the different models of human learning. So if you look over here, the behaviorism, Piaget's cognitive development, constructivism, connectionism. So we also saw this in ethics lecture just now. So there's like a different model, different levels of how this learning is actually happening. So yeah, so it's quite comprehensive in terms of the coverage. So make sure you go through them. So the second part is basically on the cognitive models, coming back or kind of like doing another recap of our cognitive architecture. So in here, we actually covered two cognitive architecture. One is the Aptar, another one is SOAR. Okay, so there is a difference between these two. Okay, so some of the model comparison that we've got is in terms of their memory types, what they're actually used for, why how learning actually happens for each type of model, what is the kinds of structure they apply for every type of model architecture, what kinds of application they have been applied in, and finally what kinds of decision can they make. Okay, so both of them, they're actually quite different. They're not really dependent. They serve different purpose. Okay, so for Akhtar, it's more on trying to understand the problem solving part, the declarative part. But for SOAR, it's more on the production memory, or how to better understand how working memory actually works. Okay. So the first part was on architecture, cognitive architecture. Second part is on how we human do transfer learning. Okay, so this is about how we are able to better or easily learn a new aspect. Let's say you know how to ride a bicycle, now you want to learn how to ride a motorbike. Okay, this is something to do with this sort of transfer learning. One is called near transfer, another one is called far transfer. Okay. And the final part, hopefully the final part of this lecture, is on the AI techniques that was developed based on human learning capability. Okay, so we wish this is in 2000. Is this already happening? Don't know, not yet. Do you want to? Do you want to learn like this?
Yes.
So you want to be AI systems yourself? Then how about that bias part? All right, okay. So yes, so these are basically some of the comparisons that we talk about during the learning paradigm and versus human approach. How AI learns and how human learns, okay, and some examples associated to those. So mainly it's covering different aspects. One is supervised, another one is unsupervised, and another one is reinforcement learning. Okay, so I don't really want to go into the details of this because I think you are well aware by now what each of them represents. But so long that you're able to do that this association, then I think you should be okay. Okay, and then we went on to topic 8. When this is finishing, feels forever, right?
Yeah.
Topic 8 is emotion. Okay, one of my favorite topic. We covered the cognitive theory of human emotion, and then we look at how emotion is used in making decisions. I think we did that, okay, and explain how emotion is actually modeled in AI systems. Okay, so we got several parts. So this is the first part. We look at the definitions of what these emotions are. Okay, and then part of the definition is basically a discussion about Paul Ekman's basic emotion. So first started with 6, then one got extended, so it became 7. And then the same team also introduced the the FACS, okay, the action coding, action coding system. So this FACS is basically this sort of representation. Okay, you're not asked to memorize all these different combinations of FACS. You're only asked to know what they are. Okay, then we look at the theories of
Believe me, like
emotions
this
in
is
the
kind of
cognitive
working.
science.
It
So
was
we have
working. I
several
don't know why,
theories.
but
These are some examples. James Lange and Bart Kashter, Singer is not how to pronounce. Yeah, anyway, it's the difference
like
on
this.
how when emotions get
Ah,
what is it?
like this.
activated, okay? And it is basically an interplay between this the when whether
Yeah,
it precedes or precedes
it's fine. I
emotion,
can see.
sorry, arousal, okay? So it's a combination of when the physiological changes actually happens for this each type of emotion, okay? Then in the next part, we're looking at emotion modeling. So this is when we try to better understand how AI systems can understand emotion from different aspects, such as the facial expression, from textual, from body language. Okay, so this is basically a highest overview of how such computation systems can happen. And we covered at least two types of emotion models. One is called OCC, another one is called PED. Okay, so PED stands for the pleasure arousal dominance. So you actually have like X, Y, and Z axis that actually represents every one of these aspects. So one is the intensity of the emotion, which is arousal. Another one is the levels of pleasantness of the emotion, which is very happy or not so happy. Okay, or like elated or just happy, for example. And dominance is how much control do you have of that specific emotion. If you feel angry, how angry do you feel? So this is dominance. Okay, so this is basically one model that's been used to represent emotions in the current systems, but it doesn't stop there. Another one is rule based, which is basically based on handcraft combinations of information. For example, if there is a high heart rate and if the facial expression is frown, then this person is actually representing anger. So not to say this is the best representation, but this is still one of the available models that's been used by AI systems these days. And then we have these categories of emotion. One is one type called categorical, another one is called dimensional. Okay, so they're different in their own kind of like area. Okay, still they're able to identify the emotion, but the kinds of data you need to provide it will be different. Okay, and finally the fourth part of this emotion lecture is basically on the creating emotion aware AI systems. So we covered quite a number of different domains. An example is healthcare. So let's say if you want to take care of the elderly, you have a robot who can stay at home and watch whether or not that elderly is basically taking their medication, or it's like they're sleeping at the correct time, or they're having some kind of the pain that might trigger some kind of warning to maybe their caretakers. Okay, so these are some of the examples of how emotions can be applied in the healthcare settings. So moving on to topic nine, okay, we look at language processing. Okay, so basically we look at how we human understand language, and we then look into the implementation of AI systems, okay, such as NLP. So we covered the components of words. So this is covered as lexicon and phoneme, and also morpheme. I think yes, morpheme. So phoneme is the smallest unit of sound, whereas morpheme is the smallest unit of meaning. Okay, and if you look at all these different, like along the lecture notes, we covered three different things, which is basically how we understand sentence and words. So by phonemic restoration effect, the frequency of the words and how well we are when it comes to segregating the speech. Okay, so we also look at how we understand basically the sentence. So it's basically based on the frequency of the words, the context of the words within the sentence, and also whether or not such word has some kind of ambiguity meaning or ambiguous meaning. Okay, so all of these will have a play in helping us to understand the context of the sentence. Okay, and we also look at the factors that determine parsing. Syntax first followed by semantics, or syntax and semantics are simultaneously covered together, which is called interactionist. Okay, so one is parsing. So we have this example: spy saw the man with the binoculars, right? So what gets grouped together? How many times do you need to read? So this actually brings us to a problem called the garden past sentence. Okay, so make sure you understand this and be able to make sense of what differs the time when we separate by syntax first, then semantic, or syntax and semantic processing comes together at once. Okay. Then in the next part of the lecture, we look at how language understanding helps AI development. So there's a brief history about how machine translation actually starts. So in the 1950s, this is when very much the rule-based systems was used before, like, a more advanced machine-based translation is being applied. So we look at the statistical machine learning approach before the more advanced neural machine approach is actually covered. Okay, so this is basically one example. So all in all, in a nutshell, this language representation can be divided into three. One is a rule-based system, another one is by statistical model, and the final one is based on deep learning. Okay, so the kind of like, the difference between them has also been covered. So you can look into them. So topic 10 and 11, not so much a topic. It was basically just you to do your project, which is the hackathon itself. So there was no specific topics on that. We went on to topic 12, which is on reasoning, decision making, problem solving. So we covered first in this order what problem solving is, how they can be solved, what approaches. Then we look at reasoning and decision making. So in a nutshell, again, problems can be divided into two parts. One is well defined, and the one is ill defined. So make sure you know what they are, what are the examples. Okay, and then you have two approaches to solving the well-defined problems. One is by Gestalt approach. Remember the circle problem? Yes. And another one is by information processing approach, which is very much algorithmic. Okay, so this is an example of the Tower of Hanoi. Okay, so then the following part of the lecture we covered reasoning. Okay, so we have two types of reasoning at least. One is called deductive, another one is called inductive reasoning. So we went on talking about how we make decision, and what you need to understand from here is when we make reasoning, we very much rely on something that is most beneficial and most cost effective for us. Okay, so if you look over here, so when you were asked to make a choice, right, for this behavior, okay, you finishing exam, doesn't matter whether you pass or you fail, which one of these choices will you make? A lot of the time, people will go for something that will not be the best scenario. It's not the cheapest, but it's the most beneficial for them. So this is what this part of the lecture is trying to show. Okay. And finally, today we conclude our lecture with topics on ethics and implications. So we talk about how AI systems can model cognitive models or cognitive concepts. And then we also look at what are some of the areas that deserve some ethical insights or ethical kind of reflection, if you can put it that way. Okay. And yes, so that actually concludes all the lectures that we have for this 13 weeks, right? And then we come to what's going to be included in final exam. Basically, the things that I have covered just now, not 100%. Again, some of them are missing, but the scope of the content that you have to cover more or less needs to be those. Okay. All right. Okay. So final exam will cover 50%, and you have two parts. Okay. You have to answer all questions. You have 25 questions in total, and part A is MCQ with NCA, right? Which means that you have an MCQ questions with multiple choice answers as well. Okay, so you have 5 options to choose from. Every question will have at least 2 answers up to 4. If you're not mistaken, four, between 2 to 4 answers. Okay, you have two questions, and it comes from all the topics that we covered just now, from topic 1 up until week 13. And then part B is short answers, where you have 5 questions, all topics. Do you want a bonus question?
Yes.
I
Make it
already
two.
say what the bonus question is. I've been telling this from the beginning. What is it?
The
Yes, okay. So they have one question on eye tracking. Okay. So definitely you will do that on eye tracking. Even if you cannot do the rest, if you can do the eye tracking one, no lah, do all the rest lah. Okay. You wanna get A. You don't want to pass. Okay. You definitely can pass, but you wanna get an A, right? From I think previous
yes.
history. Well, we had students who failed, but mainly because the student have been missing in action. Okay, so very rare for a student to fail, lah. So it's a relatively easy course to pass. Okay, so your exam is going to be on 17th of July. Are you aware of this? Yes. Okay.
Yes.
11 o'clock, right? 11:30. 11:30 until 1:30. I don't know where the venue is. Do you know?
Exam
No,
hall.
don't know yet. Haven't been revealed to you? Exam hall. Okay,
Yes.
you know which DK? Which they want? They want one. Okay, hall one. Okay, so ask your friends, update one another, don't go to the wrong exam. Okay, don't come here. Exam is not here. Exam is written, it's a closed book. Okay, not open book. Okay, so that's why we spend almost like 40 minutes, right, covering what we were supposed to do.
No, it's ours.
Okay, so yes, so we covered the entire 13 weeks lecture.